We normally think of perfect stars being like our Sun, or perhaps dimmer, with stars like Tau Cetus, or even further into the K-class, orange dwarfs, which are thought of as being more conductive to life. However, we can also look in the other direction too. Stars that are not much larger than our Sun or Alpha Centauri A are not often considered in detail. It's about time we focused our attention on them a little more closely. Hi everyone, Vega here, and in today's video we will continue our look at star classifications and venture into the F-class, a subset of stars that bizarrely, in our local area, seem to be in sparse supply. So let's get to it. The wonderful star of Procyon shines brightly in our skies, 8th brightest in the night sky, a proud yellow-white twinkle in the Canis Minor constellation. When we think of bright white stars, we might think Sirius, Vega, Altair. Bright red stars, Betelgeuse, Antares or Aldebaran. Bright yellow stars, the Sun, Alpha Centauri or Capella. So I hear you say Procyon, but what others are there? Aren't there any other stars of yellow-white variety that are equally as interesting? Well, the truth is, if we look at a list of F-class stars within 50 light years, as mentioned, bizarrely the only one in our immediate vicinity is Procyon, and after that we reach Chi Draconis, which is almost 15 light years further out than Procyon, at 26.28 light years distance. It seems quite a curious quirk that we find ourselves in such a relative desert of F-class main sequence stars. Even Procyon isn't really in that category, having begun burning helium in its core and evolved into a subgiant 4 category. As we see, once we reach the 25 light year boundary, suddenly they do appear in more frequent supply. We see the interesting star of Tabit, some 26.32 light years away, and we move out to as much as 38.7 light years before we find the first F0 main sequence category of star, the star of Porrima. The F-class are certainly quite an atypical group, at least in our local vicinity, particularly when we think that there are at least 5 A-class stars before Porrima, in Sirius, Altair, Vega, Fomalhaut and Denebola. It could be that I've missed something though. Let me know in the comments below if this is the case. Likewise, we must also point out that with the exception of Procyon, almost all of the local F-class stars are indeed main sequence stars. Interestingly, the second nearest subgiant is the relatively unknown Zeta Herculis, and third closest, Alaud, followed by the star of Delta Aquilae that lies some 50.6 light years from Earth. Delta Aquilae's luminosity class of 4 subgiant indicates that it's like Procyon, Zeta Herculis and Alaud, and is in the process of exhausting the supply of hydrogen at its core and evolving into a giant star. Interestingly, the star is actually drifting closer to the Sun with a very brisk radial velocity of -30 km a second, and so the system, predicted to come within 25 light years of the Sun in around 335,000 years, will actually transform into one of the brightest stars in our skies. In this graphic, we see the main sequence range from the top end of the G-class, the Sun, through to G0. We move to the lesser powerful F-class stars, F8 being a star that is around twice as luminous as the Sun, F6, which would be a star of similar colour to Procyon, if not a little more yellow. F4 now reaches around 4 solar luminosities, and a typical F2 main sequence star is around the mass of a Sun and a half. F0, of course, is the most powerful F-class main sequence star, and would average around 7.24 times as luminous now as the Sun, before finally we push into the lower end of the A-class, A9 and A8, which would be not too dissimilar to the nearby star of Altair. Running through again, it's important to recognise the F-class stars as stars not much brighter than, for example, Alpha Centauri A, which ends with stars that would begin to almost be pure white stars, like those in the A-class Sirius or Fomalhaut. Certain research suggests the potential for life to emerge on planets orbiting F-type stars, with life cycles resembling those of G-type stars, could have life cycles resembling those of G-type stars. F-class stars maintain stability for around 2 to 4 billion years, so a much shorter duration compared to the 10 billion years of stability observed in G-type stars like the Sun. This limited time frame does though create a narrow window for life to evolve. If our Sun were an F-type star, by its current age of 4.6 billion years, it would likely have completed its life cycle and transitioned into a white dwarf. The habitable zone around a relatively hot F0 star spans from approximately 2.0 astronomical units out to 3.7, while for a cooler F8 class star, it would range from 1.1 to 2.2 astronomical units. Despite the potential for liquid water, The received light, though, would be significantly more intense. The impact of such intense light on potential life forms remains uncertain. F-type stars emit higher energy forms of light, including UV radiation, which could have detrimental effects on DNA-based or similar life forms over the long term. Studies indicate that a hypothetical planet within the habitable zone of an F-type star with an Earth-like atmosphere would actually experience 2.5 to as much as 7.1 times more damage from UV light compared to the Earth. Theoretically, a dense ozone layer in the upper atmosphere could somewhat mitigate the issue, and indeed, without a robust ozone layer, life could still develop on the planet's surface, but would likely be limited to underwater or underground regions. In essence, it would be no more intriguing than the potential for life in subsurface oceans on the celestial bodies, Europa, Enceladus, or perhaps Ganymede. In today's final graphic, we look through some of the closest and most interesting F-class stars in our vicinity, starting with the Sun for reference. Next we see Zeta Tucanae, located some 28 light-years away. The star is on the extreme lower end of the F-class, and indeed bizarrely even has less mass than the Sun. The star, however, burns hotter and is around 25% more luminous than the Sun. The star of Procyon has left the main sequence, and hence the designation of subgiant rather than main sequence. Procyon's colour and temperature is the reason for its inclusion in the F-class, and the star obviously needs little introduction. The fascinating Upsilon Andromedae is thought to have a planetary system of 4 super-Jupiter gas planets, which we see depicted here, and Upsilon Andromedae lies 43.9 light-years away, with a luminosity considerably higher than the Sun, at around 3.57 solar luminosities. Porrima, also known as Gamma Virginis, is about as hot as it gets before leaving to join the A-class, and the star is categorized as an F0 main sequence star. Located some 38.7 light-years away in the constellation of Virgo, Porrima has an estimated 1.56 times the mass of the Sun, which leads to a luminosity of over 7 suns. Pi 3 Orionis, or Tabit, is a mid-range F6 class main sequence star, and can be found by drawing a line between Betelgeuse top left and Bellatrix top right of Orion. It is the brightest star in the lion's hide, or shield, that Orion is holding. Tabit has an irregularity in its radial velocity that is thought possible to be a planet, although thought more likely to be irregular stellar activity. Chi Draconis is slightly dimmer than Tabit at an F7 main sequence star, and at 26.28 light-years is actually the closest F-class main sequence star, when we bear in mind that Procyon is not part of the main sequence. It is one of the 40 or so closest stars to the Sun, and is thought to have a dimmer K-class partner in close proximity, with an estimated 182-day orbit. Finally, for reference, we include the more well-known A-class star of Altair, at the bottom end of the A-class with the A7 designation. Altair now burns purely white rather than yellowish, and it's interesting to compare the sheer power of Altair in comparison to the other stars we've seen today. Altair is too hot and too white to be classified in the F category. Finally, we see all the stars together, for reference purposes, encompassing the entire gulf between the yellow dwarf G-class through F, and then finally to the main sequence A-class stars. F-class stars are fascinating and unusually rare in our local vicinity, and in fact if we are looking for only main sequence stars, we have to venture as far as 26.28 light-years to reach the wonderful star Chi Draconis, thought to be an FK binary system. The F-class main sequence ranges from almost Sun replicas that burn slightly hotter, to much more powerful stars like the star of Porrima, Gamma Virginis, which is over 7 times more luminous than our Sun. The stars are thought to be the last remaining subset of main sequence stars that could potentially harbour life, although it would have to get its skates on, as the window is substantially less than our Sun. And indeed, if our Sun were hot enough to be an F-class star, it would now have been through its entire existence and be slowly fading away as a white dwarf, firing extra amounts of ultraviolet rays. These stars are troublesome but intriguing places to look for planets, and indeed the star of Upsilon Andromedae is thought to be harbouring a fascinating planetary system. Let's wait and see as telescopes improve just what other wonders we might find around some of these fascinating, twinkling, yellow-white stars. Thanks for watching, and consider subscribing if you haven't already. If you would like to support the channel further, you could consider buying me a coffee, and I'll link this in the description. Thanks to those of you who have already done so. If you have any videos or subjects that you'd like to see brought to life, don't forget to let me know in the comments below. Perhaps next week your idea could show up. Take really good care of yourselves. look after your friends and family well, and I'll see you on the next one.